All right. We are back with Chapter 8, Lesson 6, Solving Systems of Linear Equations by Graphing. So the objective for today is to learn to graph systems of linear equations to find their solutions. So we're going to be graphing systems, that means more than one equation. It's going to be two equations of linear equations, two equations of lines to find their solutions. Notice that solutions is plural. Let's talk about the possibilities of what solutions could be if we were graphing. Okay, so the first one is the most obvious. That would be if we had one solution. Okay? And if you have something with one solution, what that's going to look like, it's going to look like you're graphing a line here. Okay, that's one line. And then you're going to graph another line. And let's say it's going to be just like this. Oh, kind of slipped. Right there. And those are my two lines. This is a system. You're going to have two lines. You're going to have to do this. One solution is where they intersect. And if you see, the point of intersection here is the x part is 1, 2, 3, 4, and the y part is 1. So this is an example of one solution right there where the lines intersect. Okay? Another possibility for an equation would be something that is no solution. So if you have something that's no solution, you're going to have two lines. They're going to be lines, but you're going to have one line that, may be like this, let's say. And then what's going to happen is you're going to have another line that might be like this. Now, whenever you're solving systems of equations, you're always looking for where the lines intersect, and that point of intersection is your solution if you have one solution, right? Now, where do these lines intersect? They don't intersect at all. That's why this is a no solution. Okay? That is what something that is a no solution look like. Okay, but there's still, we have one solution, no solution. The last one is infinite solutions. Infinite solutions. Okay? And what this means is this means I have a line. Could be any line right here. Okay, this is going to be my line here. It's a lovely line, right? Do you see that line there? There is my line, okay? And then what's going to happen is there's going to be another line, the same line, directly on top of this line. So we actually have two lines, but this line is actually directly on top of that one. And so it's two lines directly on top of each other. So that's why there's infinite many solutions, because there's infinite many points on that line. Okay, so those are the three options that you're going to have. You're going to have one solution, no solution, the lines are parallel, or infinite solutions. They're really actually the same line. All right, let's get started in the lesson. So the first example, we're going to start with example 2A. Okay, here we go. We have two equations. Now, we're going to solve by graphing, which means we're going to graph both of these. Okay, what I see here is that to solve by graphing, what we need to do is we need to put them in slope-intercept form. I see that this first one is already in slope-intercept form, and that is awesome. I am good. So this one I can just leave as y equals 2x minus 7. Okay? Y equals 2x minus 7. That means that my slope or my y-intercept is -7, and my slope is 2 over 1. So I'm ready to graph this. My y-intercept is -7, so that's going to be down here. 1, 2, 3, 4, 5, 6, 7. And then my slope is up 2 over 1. Up 2 over 1, 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 and the opposite down 2 over 1. All right, where did my ruler go? Huh, oh, here it is over here. Okay. And we are going to connect the dots. Just like so. And there we go. First line is graphed. Okay, now onto the second one. Now this equation right here is not in slope-intercept form, so the first step that we need to do is go ahead and put it in slope-intercept form. And remember, slope-intercept form is y equals mx plus b. Okay, we need to have y by itself. So solve this equation for y. Simple, all I do is subtract a 3x from both sides because I'm trying to get y by itself and 3x is around it, so I'm going to do the inverse operation. 3x is positive, so the inverse is negative. I'm left with y equals -3x plus 3. That means my y-intercept is 3, and my slope is -3 over 1. All right, so I'm going to go ahead and graph this line. Okay, my y-intercept is 3. Let's do a different color. Y-intercept is 3, so 1, 2, 3 right here. And then my slope is -3, down 3, 1, 2, 3, and over 1. Down 3, 1, 2, 3, and over 1. Oh, down 3, 1, 2, 3, and over 1. Looks like I might have my point of intersection. Which is right there. Awesome. There we go. Our point of intersection is 1, 2, and down 1, 2, 3. 2, -3. So that is our solution. 2, -3. Perfect. Okay, now what we can do is let's go ahead and check our answer. Well, before we're going to check it, what we're going to do is we're going to solve this algebraically. So to solve it algebraically, we have our two equations. The first one is here. So solve algebraically. All right. So we're really going to practice what we did last chapter. So our first equation is here. Y equals 2x minus 7. And then we took this equation and we solved it for y. And so we have y equals -3x plus 3. So we're going to go ahead and use substitution, and just because 2x minus 7 equals y and -3x plus 3 equals y, we're going to set these equations equal to each other because they're both equal to y. Okay, and we're just solving this algebraically. Once we have that, we're going to get the x's on the same side. We're going to move the smaller one, which in this case would be -3x. So I'm going to add 3x to both sides. I end up with 5x minus 7 equals, those cancel, 3. I am now isolating x. And I end up with 10, 5x equals 10. Now it's time to isolate. This is 5 times x, so the inverse operation is division. And we're left with x equals 2, which is wonderful because now I'm just going to pick one of these equations. How about the first one? Y equals 2x minus 7. And I'm going to substitute 2 in there and figure out what y is. So y equals 2 times 2, because that's what x equals, minus 7. And I'm left with y equals 2 times 2 is 4, minus 7, and I get y equals -3. Perfect. I have my x equals 2, y equals -3, which is the same thing here. It's the point on the graph. So I can write my equation as my x is 2 and my y is -3. That is the point of intersection. That is the answer. Let's go ahead and check this by hand now. Okay, so we're going to check our answers by hand. To do this, I'm going to write the first equation, y equals 2x minus 7. And then I'm going to write the second equation, 3x plus y equals 3. Okay, and I'm just going to substitute x equals 2 and y equals negative 3 into both equations. So here we go. Instead of y, I'm going to write negative 3 equals 2 instead of x. 2 times 2 minus 7. Negative 3 equals 4 minus 7. Negative 3 equals 4 minus 7 is negative 3. This is a true statement, which means the x and the y value that I put on here is a point on this line. So 2, negative 3 is a point on this line. This is true. So I'm going to do the same thing over here for this equation. I'm going to go 3 times 2 plus, instead of y, I'm going to write negative 3 equals 3. 2 times 2 is 6, just minus 3. And here we go. This is another true statement, which means this point is on this line as well. So since this point, 2, negative 3 is on this line, and it's on this line, that means that must be the point of intersection, because it is the point on each of these lines. All right, so that's what you're going to have to do. You're going to have to graph these equations, solve it algebraically, and check it by hand. All right, let's go on to the next one. Example 2b. And how many solutions? Remember, there was 3 different ways. We had one solution, no solution, and infinite solutions. This was an example of one solution. So when you have something that's one solution, I want you to graph it, solve it algebraically, and check your answer by hand with both equations. All right, now we are moving on to example 2b. Okay, 2b. Now we're going to solve this by graphing. So the first thing we're going to have to do is put these equations in slope-intercept form. Slope-intercept form, which is y equals mx plus b. All right? Well, that is not in this form, so we need to solve this for y. So I'm going to do it for the first one. 2x plus y equals 9. I'm going to solve it for y, which means I'm going to get rid of this 2x. So I'm going to go minus 2x to both sides. And I'm left with y equals negative 2x plus 9. All right, I can graph that. My y-intercept is this number on the outside, 9, and my slope is next to the x. It is negative 2 over 1. Always want to change it to a fraction. All right, let's go ahead and graph this. So my y-intercept is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. And my slope is down 2, 1, 2, and over 1. Down 2 over 1, 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 and there we go. Perfect. Now we can connect the dots and graph away. Looks pretty good. Perfect. Okay, now it is time to solve this second one. Y minus 9 equals negative 2x. This is not in slope-intercept form, so we need to isolate y and get y by itself. To do that, I'm going to have to get rid of this negative 9 by doing the inverse operation, which would be a positive 9. So I get y equals negative 2x plus 9, where my y-intercept is 9 and my slope is equal to negative 2 over 1. Very interesting. If we graph this, we go our y-intercept first, up 9, which is here, and then we do our slope, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, boom, boom, boom. This looks like it's the same exact line. And if we connect those dots, we see that it is. It is the same exact line, okay? So for this one, since it's the same line, what we're going to say is infinite solutions. This has infinite solutions.